Post-lunch apathy and late-night alertness are the physical results of your most recent meal. These shifts in state are chemical responses triggered by the specific nutrients currently entering your system. We often treat the mind as an abstract concept, but the brain is a physical machine. It is constructed from the materials you consume, meaning its very architecture is built from your diet. To understand this connection, we can look at a dehydrated brain to see the raw nutritional blueprint that remains once the moisture is removed. This shows the proportional breakdown of that blueprint. It is a composite of fats, proteins, micronutrients, and glucose. Understanding these four physical components allows us to see exactly how specific foods manipulate mood, energy, and cognitive performance. Lipids, or fats, make up the vast majority of the brain's dehydrated weight. Among these, omega-3 and omega-6 are the critical components. Since the brain cannot produce these essential fatty acids, they must be sourced from foods like nuts, seeds, and fatty fish. These omegas slot into your cell membranes, reinforcing the boundaries that protect your brain cells and help prevent degenerative conditions. In contrast, the long-term consumption of trans and saturated fats can lead to structural decline, making cell membranes rigid and compromising overall brain health. Your choice of dietary fats provides the raw material that either maintains or degrades the physical integrity of your brain cells over time. Proteins and amino acids form the second major component of the brain's blueprint, acting as the building blocks for growth and behavioral regulation. These nutrients facilitate the production of neurotransmitters, the messengers that carry signals between neurons to regulate sleep, attention, and weight. The amino acids in your food serve as the precursors for mood-altering chemicals, including serotonin and dopamine. Getting these nutrients to your brain cells is competitive. Amino acids vie for limited entry points. A varied diet ensures a balanced combination of these messengers reaches the brain, preventing chemical imbalances that lead to extreme mood swings. By managing protein intake, you influence the chemical signaling that dictates your emotional and behavioral state. The brain also requires a steady supply of micronutrients to maintain its internal defense systems. Antioxidants found in fruits and vegetables intercept free radicals, neutralizing them before they can destroy healthy brain cells. This defense relies on specific vitamins like B6 and B12 and folic acid, along with iron and zinc, working together to guard against mental decline. These micronutrients serve as an active shield, preserving cognitive function as the brain ages. Supporting this entire system requires a high volume of fuel. Although the brain is only 2% of your body weight, it accounts for 20% of your daily energy consumption. This energy comes from glucose. The frontal lobes are particularly sensitive to glucose levels. Even a slight drop in supply can noticeably alter mental function. Carbohydrates deliver this fuel in three forms: starch, sugar, and fiber. The ratio of these components determines how quickly the glucose enters your system. High glycemic foods cause a rapid glucose spike, followed by a sharp drop, resulting in declining attention and mood. Slow-release carbohydrates like grains and legumes provide a steadier curve, allowing for sustained attentiveness over a longer period. Strategic selection of carbohydrates allows you to regulate the delivery of the brain's most essential fuel. The relationship between the stomach and the brain shows that cognitive function is fundamentally tied to the digestive system. Every meal acts as a delivery system for a complex chemical code. These nutrients provide precursors for neurotransmitters, the structural lipids for your cells, and glucose that fuels frontal lobes. Because these dietary choices directly affect the health and performance of your brain, your diet is a primary tool to influence your own biological function.